Our planet's climate is changing. There's no question now that what we are doing is having a dramatic impact on our planet's climate. Join me as I look at what the North East are doing in the fight against climate change. So we've seen how some researchers are working to minimise the effects of climate change, but you may have seen some reports that are saying that it's just too late, that the effects are already going to happen whether we reduce carbon dioxide emissions or not. So I'm going across to the other side of Newcastle to the Urban Sciences building to meet a team who are looking at how we can adapt our lives to a changed climate. Okay, Sarah, so can you just tell us a little bit about where we are at the moment?
Yeah, so we're in the Urban Sciences building on Newcastle University campus, and this houses our computer science school, but it's also got some specific facilities that are used by civil engineering and electrical engineering here in this building. So we've got our smart grid lab in this building here.
Okay, so what do we mean when we say a smart grid lab?
So the building itself is quite heavily censored. There's a lot of information coming from the building that tells us how it's performing. In the lab itself, we've got some equipment in there that enables us to pretend to control parts of the electricity grid so that we can see how different technologies and different control decisions might affect the way that the system runs in the future.
So the building itself is kind of almost being used as a lab to collect data itself?
Yeah, so we are using this as a living lab, and the building, we're monitoring its energy consumption, the temperature inside, the humidity, the lighting levels, and that enables us then to think, what if we controlled the building in slightly different ways? What would that mean in terms of the building being comfortable and usable, but also potentially turning down some of the demand in the building so that the local network, at times of congestion or stress, the local network can cope because we're offering some services and helping it.
Sarah showed me around the Urban Sciences building and all the cool technology that they've got, and introduced me to Dr. David Greenwood, a researcher who actually uses the data that comes from the building. Okay, so David, so what is it that we're looking at here?
Okay, so this is one of the university's smart grid or smart energy laboratories. So in this room we've got a lot of devices which allow us to both physically and virtually represent the behavior of large energy systems. So that could be a model of this building, it could be a model of a town or city, or it could be a model of a whole country or several countries. And what we can do is we can combine computer modeling with physical equipment in the laboratory to allow us to both study kind of big problems but do it in a way that is repeatable and is not going to cause a bad problem if it goes wrong. So we wouldn't be allowed to go and turn off a power station to see what would happen. What we can do is turn off a power station in a computer model and then have some real physical outputs of that interacting with some of the equipment we've got in the laboratory.
So this essentially lets you do some experiments without disrupting everybody's energy coming to their homes?
Yeah, exactly.
Okay, so why is it that we're doing all of this?
So what we're trying to develop is different ways of managing variable renewable energy and changes in the way that people use energy, because as a result of climate change we're having to move a lot of things like heating and transportation, which were traditionally done by fossil fuels, onto the electricity system. So if we're going to have a lot of electric vehicles, electric heating, that changes the way people are going to use energy, and we've also changed the way that people are going to get energy, because instead of coming from gas and coal-fired power stations, a lot of it is going to come from wind and solar, which isn't necessarily always available. So we have to have different solutions, both in terms of technology and in terms of how we control that technology, that let us match up the energy with where it's being produced to where it's being used. And we want to do that in terms of what kind of time, so that we've got the energy available when we need it, and in terms of space as well, so we've got the energy available where we need it.
So essentially, you know, if we don't have a windy day, we need to be able to get the wind energy transformed into electricity that's actually usable on a time and day that we actually need to use it.
Yeah, and there are different ways we can do that. So we can physically store it in a battery or a supercapacitor. So this set of cabinets behind you on this side is full of supercapacitors, which can store energy. We could do it by changing and incentivizing the way people use energy. So for example, if someone's got an electric vehicle, that's basically a large battery, and we could try and encourage them to store energy in that and then use it either directly, so take the energy out of their vehicle when it's needed elsewhere, or by just not charging it when they might otherwise have charged it to reduce the amount of energy
so
people are using.
charge it when we need them to charge it.
Yeah, charge it
and
when we
then
need to use it
when they like.
And we can change where energy is being used. So if we've got areas where there's a lot of energy available, so examples within the UK, Scotland has got a lot more energy than it needs, and the rest of the country is not. So we have to be able to move the energy from Scotland to the rest of the UK. But then also within wider Europe, we've got connections to places like Norway and France that might have a surplus of energy at some times. But then when we in Britain have got huge amounts of wind, if it's windy, we could then send that to them. So it's a mutually beneficial arrangement.
Oh wow, so it's bigger than just our towns and cities. It expands right across.
In our research area, we say that we're taking a whole systems approach to energy, and that's very, the whole system can be very big. Yeah, it can be
great,
continental sized.
And am I right in thinking that the building also has an electric vehicles filling station?
Yeah, it does. Out the back, it's got.
Great. Can we go see that?
Yeah, absolutely.
Brilliant. Okay, David, so why do you have electric filling station on site at the Urban Sciences building?
So electrification of transport is going to be one of the key energy uses in the future, but it's something that we don't really understand because electric vehicles are relatively new and we don't yet have kind of mass adaptation of them. So we need to be able to look at how people are going to use different charging and try and kind of understand what their charging behaviour is, so that we can see how that fits the wider issues of the energy system.
So this in itself is part of the data that's going into that building?
Yeah, exactly, and it's actually supplied using electrical infrastructure from inside the building as well.
So I guess, like you say, electric vehicles are relatively new, but they're not that new. We've been slowly moving away from fossil fuels in our vehicles to electric over the past decade or so. So why is it that we think that maybe adaptation to climate change is this new thing?
Well, I think that there's a few factors. One is that I think people are more aware of the kind of urgency of climate change. We have to take action much more quickly than we thought, and probably much more drastically than we thought. And then the other thing is, because we've had this 10 years of development around electric vehicles, the vehicles themselves are a lot better and they're a lot closer to what people would kind of expect. And so you're going to get much more of kind of mainstream users rather than just early adopters, which it would have been up to this point.
So how do we go about convincing people that a vehicle that only has, say, 100, 200 miles on its battery is a vehicle that they need or they want?
Yeah, so I think a lot of it is to do with people's perceptions and what their perceived need is rather than what their real need is. So the vast majority of journeys that people take in any vehicle are usually quite short, maybe like 5-10 miles, and it's relatively rare that you would drive more than 100 or 200 miles, certainly in one sitting and in one journey. Obviously those journeys do exist, and at the moment I would probably say as well that electric vehicles aren't suitable for every use case, but you could probably now get an electric vehicle that is suitable for most. One of the big changes we've got is in the charging infrastructure. So this charger behind us is 175 kilowatt, so that's about 3.5 times faster than the fastest chargers that were being deployed even a couple of years ago.
Oh, so this will charge your car fast?
This will charge your car fast, and there are some chargers in other places in the country that are up to kind of 350 kilowatts. So that will charge your car only in kind of 5 or 10 minutes. But that brings an issue for us on the energy side, because this 175 kilowatt charger is equivalent to about 100 domestic properties all in one place. So you can imagine if we have people using those a lot, that's going to put a lot of strain on the energy system in specific places. We need to suddenly deliver loads of energy.
So it comes back to that supply of energy from renewable sources to actually the demand in a portable vehicle.
Yeah, and electric vehicles are in an interesting position, because on the one hand, if we have people kind of treating them as they might a petrol vehicle, or if we have them just charging them in whatever way kind of is immediately most convenient to them, that could potentially create big problems on the energy system side. Whereas on the other hand, electric vehicles are also a portable battery. They're something that, well, vehicles spend 90 to 95% of their time parked, and if they're parked, they could be plugged in. And that means that we can do two things. One is we can let people charge in a way that is kind of flexible. So we'd say to you, well, someone who is operating your charging infrastructure would say to you, you'll have the energy you need at 9 a.m. because that's when you want to set off, but we'll deliver it sometime between when you plug in at 6 p.m. and 9 a.m. the next day. You don't care, but we do, because
so long as it's plugged in.
It means that we can charge it when there's more wind energy, when people aren't, doing cooking or whatever else in the evening. And the other thing we can do actually is there's a technology called vehicle to grid, which means that in some cases we can take the energy out of the cars and then use it elsewhere. So if we've got, say, 20 million cars, that's a huge amount of energy that we can store and then use to balance supply with demand. So if there isn't enough renewable energy in the evening, we could take it out of the cars and then put it back in overnight when, say, it's still windy.
So essentially, we can just think of our cars as just portable batteries.
Yeah, I mean, that's what they would be. And the real challenge is, so I'm an engineer, but I think the challenge with this isn't so much with engineering, it's more around the social and economic proposition, how you make people want to engage with that, want to give you the use of their car to do that kind of thing, make it desirable to them and make them feel confident that it's not going to affect the service they want, which is a car to drive.
Over the last few weeks, I've met some fascinating researchers across the Northeast who are front and centre in the region's fight against climate change. They've taught me so much about their novel approaches in measuring, mitigating against and adapting to climate change. It can be challenging for us to do as much as we can ourselves but feel like it's not enough. But talking to these researchers has given me hope. Hope that there's answers in the science, so long as we act on it.